You go ahead and talk. Elijah, baby, you gonna have to learn how to move on, baby. It's been 30 minutes. You're gonna have to get that together. All right, we made it there. You know what? You had a short activity on functions. It says visitors to a farm can pick their own apples. It costs $1 to enter the farm and $2 for each pound of apples. Is that total cost of picking apples a function of the weight? If so, is this function a linear function or a non-linear function? It says I can think of the problem description as a real low and a rule that tells me what to do to a starting value to get a final value. The starting value or is the number of pounds, the final value or, and you're going to look at this, the weight and total cost, those are your input and output. Input is always simply X, output is always simply Y. Find your math, wherever it is. If he said I can use this thinking to make a table, we'll go in that table. You can look down at the chart. 1 for X, go up, it went over to 3Y.
5.
5. Anybody write an equation for this scenario? What you got, Desi? The only one who did that got you +5 for your homework. Cost 1 to enter the form and 2 for each pound of apples. For each pound, kind of let her know that was the slope. And then at $1 to enter, that's what I got to pay starting off. So that was the initial value. So you could have wrote the equation to help get you there, or you could have just looked at your graph and saw what they cost it. It then says, I know that a blank function is a rule where each input has exactly one output. It then says the table shows that this rule is a function, the blank. A picking apples is a function of the weight. So when we talk about functions, although we know we look at the X, when they write it, it's going to be the Y to the X. So that's why they got total cost to the weight. It then says I can use the table to make a graph of the function. The graph shows that all the points lie on the end. Straight line, you could have connected your points so that you can see. It then says this means that this is a linear function. Any questions about it? It was just a short homework we dealing with vocabulary. Jamal, did you check that login information I sent you for STAR?
Miss Harper said she checked because I used the same name there for yours.
I sent it to your email. Did you check it in your email? I'm gonna see if I find it again and I'm gonna send it to you. I got your correct login information.
Yes, ma'am.
All right, the rest of you can put your Chromes up. Those of you that need to finish, I read the math, you can go ahead and do your best to go ahead and work on it. The Chicago, go to Renaissance so you can do your STAR math. Check your VIN if I didn't already give it to you. What? Maybe they'll get you another one before then, Shantasia. They out of them because they're not replacements. Should be in alphabetical order. Find Mitchell up top. Mitchell up top somewhere. It's under your name. Yeah, look under your name. Ain't nothing in there. Then I must have gave it to you yesterday. It was on a small sheet of paper. Check and see. It was on a small piece of paper. If not, I'll double check and I'll try to get it to you. You got to write some notes. No, this should already be in your notes. Analyze a linear function. We should know that a rate of change is another name for a what? Slope. Yes. That tells us the rise of a run. We learned before in order to find slope, we need what 2 things? 2 points. 2 points. If you don't know that, definitely get it, but you should already have it, so we need 2 points. It's known as the rise or run. Rise because it's a vertical change, vertical go up and down. That's why the Y is on the top. And then the horizontal change go across. That's why the X is on the bottom. And that's how we find slope. After we get those two things. We should know Y intercept. Another name is called. And that tells me what?
Coordinate for the point where the graph Y intercept.
Where it crosses the Y X. So some of these kind of should just be in your head. When I think about it, I should know Y intercept. Automatically think about that Y X. And then it says rate of change in initial lag can be used to write out an equation. What's the equation of linear function? Good job, right? M plus B. Remember, M is the slope, B is the Y intercept. For those of you who may or may not remember, B is the Y intercept, M is the slope. You got all these, right?
We got it yesterday in her notes.
That's it, you should already have all that, right? Yeah, you should have. So we're gonna use that information. You should have your math notebook in front of you. We're gonna use that information. Need about 1 minute. See if you can read this and figure out what they are referring to. And Jamal, when you log into Clever, instead of clicking on the blue Renaissance, it's a white Renaissance. If you click on the white Renaissance, I was told that you wouldn't have to put in your login information.
Yeah, that's what I did. The new Renaissance place. The how it lit this now.
You said that's the one you used, the new one?
Yes, ma'am.
Okay, I'm gonna have to go back and check then. ADMIN 21. Huh? All right, what page you did? For each mile, good job. So make sure y'all pay attention to all the keywords for each, per, any of those kind of let us know if we're talking about slope or the rate of change. So yes, this will be the rate of change or the slope. And then $3 per passenger would be the Y intercept. If you get confused with which is which, ask yourself, what do I have to do before I do anything else? And that'll identify what's your Y. So that'll be something I got to pay before anything else. And then that each should be my rate. Questions about it? You sure? You see another problem like this, you'll be able to identify your slope and Y intercept. All right. Yes, ma'am. I don't even be on Instagram like someone. And I show her, you know, if I did, I'm sure I probably would be glad. But I ain't seen that one.
Look like my face. I can see my story from.
That's what you got me.
I'm just playing. Was 0.1 X is the slope and 40 is the Y.
All right, now we need to put that in relation to what this scenario was talking about. I agree with what you're saying. 40 is the Y. Folks, 0.1. Now, we need to put that in this context. What's going on? What are they talking about?
The telephone plan.
Telephone bill. What do I know? Now, you already said 40 is the Y intercept. What would that 40 mean in relation to this scenario? Okay, so that'll be the regular monthly amount. All right, you said that slope intercept was 0.1. Once again, after I said, what does that 0.1 mean in this scenario, in this relationship? 10 cents per minute. So you will have at least 2 or 3 questions where they're gonna be mainly just asking you to identify the slope and Y intercept in relation to the scenario. So stop and think about what the scenario is talking about, and then ask yourself what to do. In order to determine which is which, go back and read what's going on. They said we got a regular monthly amount plus charges for the number of minutes. So that would kind of let you know what words to piece together to help you see, okay, that would be $40 for the regular amount, and then I do an additional 10 cents per minute. Me and the boys, and the person had a conversation about this. You all are lucky nowadays with your cell phone plans, but now everything is pretty much what? Unlimited. Ain't gotta worry about that. Back in my day, when I was coming through junior high and high school, we had plans out like this, pay about $50, then they charge about 25 cents per minute. And then they would charge us per text message. So imagine when your friend's going through a fit and trying to send you all them messages or she mad at somebody. But the good thing, it was free after 9, so we just tell everybody, hey, just wait till 9 o'clock and call me up. So you're gonna use my minutes up. Amount. What's like here? Like, it was a struggle. When I say struggle, it was a struggle. Yeah, we had little mobile telephone place. That's before cell phones came about. I ain't that old. I ain't that old, but yes, my parents grew up with a page. I ain't in the page there. That ain't me. Yeah, we'll discuss that later. Elaine is trying to go a bike race. She makes this graph to show the relationship between time and distance, and she maintains her plan speed. They told us to write an equation and then identify the slope and intercept and explain what it means in this context. How can we get an equation that gave us a graph? By the dot. By the dot? What the dot said to look? By the line? What is that? What's that use of negatives? All right, she noticed left to right is going down, so that's one thing to know. We're gonna have a negative slope. Somebody mention the dots. What else these dots in this line telling us?
It's not linear. It's not linear.
That what you saying? The what? Coordinates? What do I need coordinates for?
The time,
Rate of change. Give us 2 points.
55.
40 and 10, somebody said 60 and 5, okay?
It's gonna be Y2 minus Y1, X2 minus Y1.
All right, good job. That is slope formula, Y2 minus Y1 divided by X2 minus X1. Remember, label your points if you need to. X1, Y1, X2, Y2. That way when you start plugging them in, you won't have to go back and what was the number? So what's Y2? Y1? Look at here, Y. X2? 60 minus 40, good job. So that's why I say label. Label, you can easily just say, okay, X2, Y2, stuff like that. Negative 520 can be simplified to the bottom is 4, top will be 1. So that's our slope, negative 1/4. What's our y-intercept? Now notice, we had already identified that we have a negative slope. So if we would have solved this and had something different, we should have went back and checked because we know it has to have a negative slope. So that's how you can look at that diagram sometimes it's positive or negative if you're on the right track. Y-intercept. What you mean?
Like,
Not the whole y-axis. Why? Y'all looking at X. We need Y. Somebody said
0,
20.
Oh,
I said 20. All right, so kind of reminded us that the y-intercept is 20. What's our equation? Good job, plus 20. And that's because 20 is positive on this y-axis. All right? The second part of that told us to explain what it means in the context of this problem. Now, before we start trying to explain, let's stop and think. What is going on?
time.
Right.
So we know she riding the bike.
And she wants to know the relationship between
Time and distance.
Did she maintain her plan?
So let's think about that y-intercept. What does that y-intercept was? 20. What does that 20 have to do with this girl and this bike race? All right, now will 20 be the distance from the finish line? Or the overall?
The overall.
So then we'll say y-intercept of 20 is the total distance. Total distance, going 20 miles. So now let's think about that slope. What is that slope of negative 1/4 telling us?
The time it takes her to finish. Then the overall.
Two of the same word, time and minute, time.
The overall time.
Overall time per what? Mile. Now notice, slope is always going to be 2 parts. You're going to put the x and the y with it, but for that y-intercept, it's simply just that y. What you mean? Oh, on the bottom. Rise or run. Run, go across, rise, go up and down. That's this piece. That's this piece right here, rise over Rome. All right, so it's negative. Somebody said something over here. I told you to fix the word with time and minute. Which one coming first? Time or the math? Time. So negative 1/4 minute per what? Per mile. Now remember with slope, you can always throw in that per, let us know you kind of come from in. So the slope of negative 1/4 is a decrease. We're gonna change the word to decrease, so now they want us to write it out or explain with me. A decrease of 1/4, you said what, minute per mile? You might need to put that backwards, mile per minute. Oh yeah, we write that Y over the X. I told you wrong. 1/4 mile per minute. So I mean, every minute she's going 1/4 of a mile. Every minute. And looking at that diagram, she did finally reach that 20 miles. How long did it take her? 80 minutes. 80 minutes, that's an hour, 20 minutes. What she in? Oh, she on the bike. That's like going from here to almost to maybe.
Oh, yeah,
On the bike. On the bike, man. Now, if I do that on the bike, if I try to ride my bike to work and ride home,
I'm going to take about 2 hours.
what you saying? It's not over.
Oh.
I said McGee now. I said McGee. So yeah, then 13 got the little curve, the little hill. I'll be down at the bottom of the hill just waiting for somebody to come and school. And if I do 20 miles, I better be all fine. My stomach better be sucked in. I mean, everything better be right. If I ride 20 miles on the bike.
I need to know the stuff.
That's a different too.
Who? Oh. Yeah, he said he's from Jackson.
Oh, everybody did. All right. Now they gave us a table. They want to know which equation describes the function shown in the table. Now, yesterday we said if we have a table or we have an equation, we can do something. Start with an X. Substitute. I'm going to give you about a minute. Now, when you substitute, you will only substitute the X values. Nope. You check the Y values. So you substitute in -2 in each equation for X, and then you got to see if you get -5. If you do, try another number. If you don't, that means go to another equation. You got 2 minutes to see if you can figure out which one works. Substitute the mean for X. Only the X you substitute.
I got this video.
You want to try? Girl, my calculator works good.
My calculator probably don't know.
My calculator works. No, I got it from church. You substitute. Did you finish the
Give me my shirt. Give me that.
This, now give me what I need to say. Which one works? Talk to me.
Like, because,
Admin, AD,
I think so, they just took time.
AD, MIN. Talk to him. Talk to him.
Negative 2 times 3 is negative 6. What's right? Negative 5. No, not
All right. Always try to leave more than once row one because you gotta work for all of them. Now sometimes you'll find that person gonna work for pretty much about all of them, and then they'll throw you off. So did you try another number? Negative 1? Forget. Plus 1? Did that work? All right, look like that's it. Still be it. Now, when we went over tables, when I just tables, when we went over tables, I told us it's one way we can find that y-intercept in the table. Everybody knows. How can we find the y-intercept in the table? Should be. Oh, it's over there. Well, what's 0? Look in the brown.
Order. Something, no,
Enter. Thank you. So if you do not know that, definitely make sure we know that. When x is equal to 0, that is our y-intercept. When x is 0, that other value is our y-intercept. For those of you who did or did not notice it. So that could have been, or at least that's always my first place where I'm looking at. Do they have the y-intercept, and then I'm going to check my equations to see who does and who doesn't. D did not, so I automatically knew to eliminate it from the beginning. So that's one way of helping you to eliminate those that don't work and all that kind of stuff. Definitely nudge Makeda. Nudge Makeda. Any questions about it? All right, I'm gonna give you about 1 to 2 minutes. Have a look. Think about it carefully. Think about what we know about slope. We need 2 points. Think about what we know about y-intercept. Yeah, so hot. That's why I keep coming back here. Oh, you won't remember that. I think it's Now just told us, think about what we know. Slope needs 2 points. Y-intercept, think about all of that. A lot of y'all still doing a whole lot of guessing and looking and guessing, and your pencil ain't picked up none. And you do the same on my work. Knowing I'm gonna do what? Yeah. So definitely make sure y'all thinking about this. Don't tell me you think. I don't deal with thinking. I need to know you know, and you got some proof that you know. So tell us what you know, why you know it. Anybody, what do we know? But see, I wouldn't even do slope first. All right, she said slope positive, it's increasing. All of them are positive, so that's good. Sit on your page. It's 3? You sure? All right, so that's somewhere else to look to go ahead and eliminate. How do I find slope? So that means I need 2 what? Give us 2 points.
2 and 4. And then 1 and 3.5.
No, I ain't doing that one.
1 and 6. We don't even got 6. 0,
All right, remember I said label your point. X1, Y1. X2, Y2. The pencil still ain't moved. When it's time for you to do it on your own, you're gonna be stuck. Come on, man. 2 minus 4. Good job. 2 minus 4. Negative 2 minus 2. Check that. They got the same sign. Positive, negative. That's negative. So then 2, 4 simplifies to
1.
would it be positive or negative? I got 2 negatives. Division. Yes.
Wait, how long is it? Because the graph.
Negative divided by negative is positive. So y'all still gotta remember your energy. So now I can say my answer is A. I got proof where the why that y intercept is, and now I got proof that's my slope. Y'all know me, I don't do no thinking, I don't do no guessing, none of that. Make sure you're able to clearly prove what that is slope. It takes you 5 seconds. Find 2 points, put them in that formula, and then get it. I'd rather you do that and get it right than not do it and get it wrong. Yeah. And then we discussed this on yesterday, right? That's when you have to attend to precision. That's when you going back checking your stuff and making sure it's correct. You thinking? I don't do thinks. I'll tell you that's always the difference between that 3 and that lower 4.
Math is hard.
No, it ain't. Math repetitive. Everything we do is the same. And then I keep telling you, once you get it here, you ain't gonna have no problem in algebra 1. If you get it here. Slope and y-intercept, that's how you're gonna talk about algebra 1.
That class, they was talking about, they was doing prefixes. They weren't even hard. They doing prefixes. They doing what? Prefixes. Like in English. Yeah. That's a real ring.
It's just typical. Just on my food, my really Now y'all see a problem like this on the test, and everybody just go through pick a song, and then the kids you're gonna go through and mark it out. A lot of us do not read. Yes, it looks like a lot. It does. But I promise you break it down and will not be that simplified. It says a trainer for a soccer team keeps track of the amount of water players consume during practice. The trainer observed that the average amount of water consumed by the team is a linear function of the temperature. It then says the graph and the equation for the function are shown. So they gave us this graph and then they gave us an equation. Anybody ever seen these little numbers on that graph? No. Okay, so when they do a little squiggly line, that tells us that notice our numbers. We started at 0 and then they jumped to 74. So anytime you see a little squiggly line, that means they skipped a few numbers because we don't need them. All right, so looking at this, A said, what's that? Well, if nobody never told you that, you wouldn't know, you know. A said for every degree increase in temperature, the average amount of water consumed increases by 0.875 gallons. What might this be written?
I guess that's
Reread me on what it says. It says for every degree increase in temperature, the average amount of water consumed increases by 0.0875 gallons.
Rate of time.
That is correct.
Yeah.
So then if you look at that graph of that equation, what's the rate of change?
2. Okay.
They gave you the equation.
Oh,
Is that same thing they had in that scenario? So that would be true. B said when the temperature is below 74 degrees, the team consumes no water. I say false.
What I said it is, what you see
that is? Below 74. We don't see below 74?
in the middle, it went up. In the middle, it went up. You see that?
Yeah, we got some in it.
No, that's something like me.
Hanging on.
Nah, she put that on me there. I hate my man because then I
Keep them going on.
And he worked anywhere. So mom said she didn't pick up with her.
It said below 74. The sketches that told you when they had a little squiggle, that means we can't see that stuff.
So we don't know what to do. That's a false. That's false.
Why you say false?
Because we don't know what the answer is. Yeah, we don't
They
see
there.
that.
No,
No, it's true. It's true.
We don't know how much water they consume.
Don't know? Huh?
So you said the equilibrium line is like the numbers in between 0 and 6.0.
Okay.
So there's no number in between them. What you said is false.
I said false.
And look, now, he also noticed on that y-axis. He also noticed that y-axis. We didn't just jump from 0 to 6. 74 is at 6. Now, although we can't see that other stuff, but we still can kind of assume that that graph is going to keep on down and on down and on down. Here, you need to correct that. I think your class had true. You had it? Okay. C said when the temperature is 86 degrees, the team consumes somewhere between 7 and 7.2 gallons of water. When the temperature is 86 degrees. Between 7 and 7.2. True or false? True. So we're gonna go over here to 86 degrees. We're gonna go where it crosses. Yes, it's in between 7 and 7.2. True. But that's what I'm saying. It's a whole lot of words, but if you read it and piece it together, it's not so bad. D then says the amount of water consumed by the team decreases by 0.45 gallons for every degree the temperature falls. It's increasing because the temperature is going what? Going up. But they said if the temperature falls. So if I go that way, it's gonna be doing what? That's true. That's true.
But they don't get it wrong. It's false because.
Then we had it wrong. It's true. Because you have to recognize. Now this temperature is going up. So when they say temperature is falling, that means I need to go the opposite direction. So if I go opposite, my amount is decreasing. You see that? It's going down. So I say it's not all about looking, that's what got to kind of convert it around. Huh? Rate of change in the what?
The rate of change in the decreasing is 0.45 gallons.
No, that ain't the rate of change.
That's what you should be asking.
Temperature falls. And if you look at your graph, the temperature is doing what? Increasing. So that means I gotta think about if I go the opposite direction with the temperature decreasing.
Yeah. So it's true.
If you want to replot this and you got your 94, your 92, 90, it's gonna go down like this. Instead of going up the way it is. It's just the difference in the words. Tell what you say now? I'm thinking about what you said. It be these, my little plugs. Fresh, I got some spray and stuff back here, but it be my little plugs. Like, oh, right now, I don't like telling people to come do it. Since you've been there, I'm probably telling you put it back. Oh, I don't know what you got. I don't know it.
You don't know what he got, and you don't know what he got.
I'm trying to see what you telling.
I was saying that because it's decreasing by 0.445 gallons for every degree.
Like, go.
I still can't hear what the boy telling. Say it again.
Because if you look at the function on the right side, it says that the initial value is 0.45. But over there it's saying that it drops by 0.45 gallons for every degree. So they're saying that the rate of change is 0.45.
I understood nothing you said.
I do for the others didn't notice that, and I can't point it all morning. But every degree, he just reminded us that it's representing rate of change.
Good job, Connor.
And 45 is the y-intercept. So in other words, they got the wrong number and place on what it needs to be. Oh, which ain't really wrong. And ain't none of them other children mentioned it. So now we got the rationale behind it. So definitely make sure we checking those words. It said every should have been an indicator. Hey, that's dealing with something with rate of change. I love it, Connor. She all right. She gonna be in uniform today. No, it ain't. All right, I'm gonna give you about 2 minutes. See, y'all waste too much time yapping. Then I give you a test on Friday, and everybody in here fail minus 3-4 people. We looking for a negative slope. Notice each answer choice they gave you 2 points. I don't have to remind you of what you need to do with those 2 points. I ain't gonna say that, Kennedy. I ain't gonna say that. See, you set them up, don't eliminate nothing.
I know.
You don't know. You don't.
Yes, I do.
Did you finish already? You finished? Did you do some math? Oh, never mind. You finished with that? You can use what you think. Yeah. You wasting your time instead of putting that in that formula. Y2 minus Y1 divided by X2 and X1. That's the wrong person you think about to try to rationalize it. Because then when y'all have any work. Stop guessing and thinking and put it on paper. All right, I got 6 minus 6. And 10 minus 3, that what you said?
Yes, ma'am.
I really need y'all to stop looking. I promise that make a difference between you getting up there and you getting down there. All right, so we need one that's negative. Same process. X2 minus X1. Y2, Y1. So looking at B, how will we set it up? Good job. 0 minus negative 5. 0 minus negative 2. 0 minus negative 5. Negative and negative change to 5. So that means 0 plus 5 to get 5. 0 minus a negative 2. That ain't negative. See?
3 minus 9, 20 minus 1. And
Somebody ready to throw that out early. I'm like, I know that ain't gonna be negative because both of them positive. That's why I say do not depend on looking at these numbers. Until you can prove it, you better assume they all right. So let's change to 5, so that'll be negative 3 plus 1. 3 minus a negative 3, which change 3 plus 3. Positive, negative. Good job, negative makes fun. C and D will be right there. So get in the habit. Stop looking. I promise you, stop looking. Take that 30 seconds to put it in that equation, tap in the calculator, and make sure that that slope is positive, negative, or 0. Don't look at it. Questions about it? You got it? And slope, I promise, and that's what I'm telling y'all to put that in that form. If you get in the habit of doing that now, when you get over there at the high school, you won't have no issue. But if you refuse to do it now with these small numbers, when you get over there with these big coordinates, it's gonna really be, it's gonna blow your mind. Uh-huh. I think we need to start.
I read.
Yes, you are right, Jamal.
A 50 gallon rainberry. Never mind, I got bad quality.
That might be because is Jamaya in the same room with you?
Yes, ma'am.
Yeah, one of y'all gonna have to move to another room. But thank you, Jamal. That's all right. Somebody picked up Jamal. We're trying to read it to us. All right, so they want us to write an equation, and then they want us to graph. What are they telling us? What's going on?
10 gallons.
Field to capacity. What might that be? What tell you negative? It drains. Good job. So what will be our equation? Good job. So now they want us to graph it. Which one can I easily graph? And where should our y-intercept be at? So 50, go ahead and cross that your y. You still got your grid from yesterday? Your graph paper?
Oh, I got mine.
Okay, that's fine. If you don't have it, that's fine. If you got it real quick, go ahead and put you 50. You can count by 10s like we got up here. All right, now my next question is, how can we graph this? Because I know we're gonna need more than 1 point.
Oh, go down, and then go.
Go down and go down, go to 10.
No, go over to the right. And then go down. Well,
I'm with you with the use of 1.
what about go from?
I don't know about going across. Start with an S, start with an S, start with an S. Yes. I need y'all get in the habit of putting some work to verify. Well, I get what you mentioned, but we got somebody who gonna need to see that. So we can substitute any of those X scores. 10 times 1. So now we got -10 plus 50. 40, which would be 50 minus 10, which would be 40. If we put in 2, what's gonna happen? Where we gonna be at? Don't come out with a recognize each time we lose in 10. So that'll be -20 plus 50 to get us 30. So each time we lose in 10. 20, 4,
0.
and then after 5 minutes, it's all gone. Linear function.
It is a linear function.
So when they give us an equation, substitute. Do not rely on looking, don't overly think. Put it in there and verify. Make certain that you are correct. Y-intercept, we pretty much know how to find that on that y-axis. Continue to use that y-axis. I always get you that y-intercept. Slope. What 2 things do I need? I'm saying with slope, what do I need? 2 points. Do not forget slope. Get 2 points. You get 2 points, that's gonna help you determine if it's positive, negative, whatever. Also told us we can determine the way it looks from left to right. The increase in left to right positive, decrease in left to right negative. Those small little things is gonna help you determine if you are correct or incorrect. How many questions you gonna have tonight? 3 questions tonight. Use your notes. Use the strategies we're talking about and give it a try. Get your belongings together. Okay, Jamal. I'm about to go on my planning period, and I'm gonna check your start login to make sure that we can get you correctly logged in so that we can get that data. Okay?
Yes, ma'am. Have a nice
I'm
day.
gonna send you an email in about 10 minutes. Okay?
Yes, ma'am.
All right. See you later, you and Jamal.
I grew on my already math.
Yes, I got your already math. We gotta correct that star math and see what's going on with your logic.
Yes, ma'am.